Okay. Hello. All right. Today we have to show you applications of logs. Take one of the green sheets and pass these around. By applications, I mean, hey, there are usefulness things to this. Like maybe Angel has a summer business and he made $5,000 over the summer, and he wants to be like, so I put my money to work for me. I want $6,000 by the time summer comes around again. How much interest does he need to get on his investment to make that happen? That's solved with these problems. Did everybody get a green sheet?
Isn't it similar to like SAT math?
I remember doing something with this.
Yeah.
I didn't care enough
Okay,
to actually.
does everybody have a green sheet? Angel, could you work with Frank today? You didn't have green always, right?
No, I just didn't know what my solid word.
And yours are gone. Okay, so we got some application things going on. Can you guys look at the top of that green sheet? So here we're telling you, I should, Sophie? I need to give you more detail than what's written here. The temperature of the pizza in degrees Fahrenheit is modeled by this function, where time in minutes since it came out of the oven. Okay, so that equation is temperature of the pizza. We're all about pizza. Dante, have you ever eaten pizza and like too quick to eat it and you go to take a bite and the melted cheese bursts the top of your mouth and that's just
ruins everything.
It does, because then you're like, and it peels off all week, it's disgusting. Good to share, yeah, sorry, it seems like, ew, didn't need that visual. Okay, so, first question here, how hot is that pizza when it comes out of the oven? Really hot, okay. What time is it when it comes out of the oven? 0. So, plug in 0 for little t and tell me what is the temperature of the pizza at time 0. You do not need a calculator to do it. As Virginia saying, it's just e to the 0 plus 1. Virginia, did you get my email? Filed it? Thank you. So how hot is the pizza when it comes out of the oven?
190 degrees. Yeah.
190 degrees Fahrenheit. If it's degrees Celsius, it's like the bread is boiling. Okay, so the next question, one of your friends is meeting you at Andy's Pizza, but you're hungry, you've already ordered the pizza, and they say, I'm gonna be 15 minutes late.
We'll be pizza when you get it.
Okay, well, some people that, you treat your friends, that's fine. Figure out the temperature of the pizza in 15 minutes. And this one, you need a calculator. If you don't have a calculator, the crappy little blue ones don't do it. Teddy, there might be some that you can find. If you have your Chromebook, you can use the scientific calculator or Desmos, whatever you need. hopefully, let me, hold on. So, one person just pointed out, what I round to, because we did not give you any details. For AP Calculus, they don't ever tell you what to round to, and they just say 3 decimals. How many people? 5.739. They want 3 decimals. Does it make sense to have 0.739 people? No, and they don't care. Significant figures be damned, welcome to math. 3 decimals. So, I would keep that here, even though, like, 0.739 minutes, really, do you think those 4 seconds are gonna make all the difference in the temperature of that pizza? Probably not, but just showing you. So some of you, could you write down on the whiteboard what you guys got? If you got different numbers in your table, make sure that you check. Okay, I see 139.315, 139.315, 139.3. Okay.
Decimals, guys.
Okay, so 139.315. So guys, right up here, I have this typed in. Can you look, please? I want to show you something. So I typed in exactly what's here. 71 plus 119 e to the negative 0.037 times 15. Gonna hit enter if I could make the cursor show up. And I got an error. Okay, so I typed in exactly what I saw. Could you look at that though? Your calculator, it says, should I just quit and like you retype? Or do you want to go to and see where the problem is? Yeah, I would love to know, because I thought I typed exactly what you asked for. What's wrong? It's blinking on it. That, I typed in the subtraction sign, not the negative. So, just because it's not a mistake that I would see. Like, be like, it's exactly what it's supposed to be, what's wrong? And you guys will flip out on the test or the quiz or whatever. If there is a go-to, highlight that and go there, and it will hopefully be blinking on the character that's causing you some trouble. Maybe you've got an extra parentheses, the wrong kind of parentheses, the wrong kind of subtraction symbol, but just wanted to show you some little troubleshooting. But you guys all got it? Anyone not get this on a calculator in some manner? Okay, the hard question is number 3. Anya, how do I set up something to solve for number 3? This is the equation for the pizza temperature. Okay, well, it's, right? What's your opinion
On what?
how to answer the next question?
I would say just start with 170 and kind of like work backwards.
Where does 170 go?
Like, well, it's like the final answer, so I would think like in front of the equal sign.
Okay, the optimal temperature of the pizza is 170.
You start.
In the problem itself, the temperature of the pizza can be modeled with this function. So, Gray, I think what you're saying is to make this
Yeah.
become 170.
Yeah.
Yeah, okay. Okay. Too many pronouns. Just make it this. Like, which it.
Yeah, sorry, I'll be more specific next time.
Okay. Byron, next step.
We subtract, sorry.
Subtract the 71. And we get 99 equals 119 e to the negative 0.037 t. Zara, what now? 5 by 119. Dante, what's next?
Treat it to exponentials.
Change it to log. So, Ray, how do I do that? Change it to log. Log or natural log? Natural log.
Yikes.
Now see what, I mean, she was right, that's our thing, but, what,
I have a question.
yep.
Oh, never mind, actually. I see, never mind.
So natural log and E undo each other. It's like add 3, subtract 3, you end up with what you started with. So natural log and E are inverses and this drops out all on its own. So Amory, what's the last step?
Divide by negative 1.
Okay, so type it in, tell me what you get. Write it on the whiteboard. You don't have a Chromebook or a calculator?
How do you put it in?
It's positive.
Trying to put it in just what it is right now. You just press LN.
I think you have to,
So
I
we
think
were
you
right.
have to put parentheses like in front of the ln, so that then you can divide the whole thing by the
Okay,
negative.
so people are wanting to say wiggly 5. Is that 3 decimals? No. Because, alright, and some people in the earlier classes, they were like, oh, wiggly 5. I'm like, you know what? No, because the way they solved it was they just looked in the table and found the nearest whole number that was close enough, and that doesn't work. I need 3 decimals or more decimals than wiggly 5. So one group is saying 0.49. That seems off. 4.9, Ella, would you- 4.923.
I got zeros and
4.973. Okay. 4.973, okay. Let's try.
4.9. No, it's not negative. I think it's negative.
The parentheses for the big thing. So you just put a parentheses before the LN and
Okay, so I'm seeing that right answer on most of the boards. Those of you who didn't get that, Stuart, are you seeing whatever got typed wrong? You dropped some parentheses.
Oh, I
It's
typed
0.7.
0.37 instead of
0.037, okay.
Negative 0.37.
Cause your number, yeah, was off by a shift. But it,
Yeah, I got it right.
okay, cool.
I keep on getting 4.04, but I'm not sure, like.
You said 3 decimals, right?
Yeah,
Fine.
okay. So this first set of parentheses is making things confusing. Okay, so natural log of 99 over 119, not 115.
That makes sense.
Okay, all right. Anyone else, like, so we had a typo and we had a misread. Anyone else not getting this answer? Okay, can you do the last one? When does, like, repeat the process and tell me how long it takes for the pizza to get to be 100 degrees. I hope there's still a pass over there somewhere. I haven't seen it in a few days though.
You can have that one for the second
Yeah. What was your like little like the ln 29 over 119? And then divide by that thing.
How do you guys 29?
Isn't that what 100 minus 7 was?
I know.
I'm not positive about that.
So we
Wait,
could
I
get a
messed
number?
up. Yeah, you're right.
I'm getting it right now.
Yeah, you're right.
Just looked like you were about to hit enter and get an answer.
I got
What's going on?
38,
But the parentheses are so weird.
So I see on 2 boards 38, 3 boards 38.158, and I heard a few other groups say that. So it sounds like, and what was the 4th number? 5. So, those of you headed to calculus. It's like, I forgot that I changed the color. In calculus,
Just like working on
not only do they not care about significant figures, they don't care about rounding so much. This is, anyone in computer science, this is called truncating. You can just cut it off. So 38.157 would be accepted. Correctly rounding, look at the 4th decimal. If it's a 5 or above, round it up to an 8. I'm okay with either way. All right? Can we look at the things at the bottom? All those words. There is a function called Newton's law of cooling. We create it, we recreate it in calculus every year. It's done with integration. It's a real topic. So, guys, looking at this, Newton's law of cooling has all those things to it. What do you think that little t stands for? Time. And Gray, you're right. I needed to tell you is time in minutes and hours. I need to say. So it needs to be specified. Is there something not working right?
No, we're good.
What do you think that capital T of little t is? Temperature at a particular time. So capital T of 5 is, what's the temperature in 5 time units? Okay, now the first one that you probably don't have a good guess for. Capital T of M. That it's a capital T, what do you think that means? Temperature. Anyone? Good guess. It's temperature of the environment, the room, whatever the medium is that it's sitting in. So if you take that cake out of the oven and put it into your 75-degree household, to cool in the kitchen, the temperature of the kitchen is 75 degrees. If you take that hard-boiled egg or that boiled egg out of the boiling water and put it into an ice bath, it's the temperature of the ice water. So it's the medium that you are soaking something in or standing in. You take the clay pot out of the kiln and you put it in the 68-degree classroom. Okay, so T sub M is your ambient temperature. Is anything ever going to cool off below the room temperature? Because some of y'all are going to be like, that thing is rock solid frozen. I'm like, how is the coffee going to freeze? If it's in a 70-degree classroom, how does the coffee freeze? I don't know. Some of you come up with it freezing. Science friends, T sub 0. T initial, it's what is the temperature of that pizza, that cake, that clay pottery, that hard-boiled egg, when you first take it out of its oven, its kiln, its boiling water. Okay. So the last one, anyone in physics? Yeah? Do you know what friction coefficient is?
Like static versus kinetic.
Okay, so like if you're on a slide and the slide is made of glass and you're sliding down wearing denim jeans, there's a friction coefficient to how much your jeans are going to stick onto that glass, that board, whatever you're sliding down. Or if you're sliding down wood and you've got, I don't know, steel marble, something. There's a friction coefficient and it depends on what two objects you have going together. Is it glass and wool? Is it steel and wood? There's a friction coefficient. Like, those of you not in physics, does this make sense that how much scritchiness something has, it depends on the material. Okay, so every object has its own kind of amount of ways that it cools. Water cools more slowly than cake. Potatoes cool more slowly than cake. So this number is specific, it's some random constant that's specific to the substance itself. Friction on a rug or a carpet, it's going to be more friction than on a smooth glass surface. Tomorrow, we're going to go through and calculate K. We're going to figure out K for a dead body.
Really?
We're not going to have a real dead body, Gray. I know you're excited for that, but
Okay.
Hunter.
Why dead body?
Why dead body? Because it's kind of cool. Like, okay, yeah, take the cake out of the oven and like, can you ice it yet? No, the icing's gonna melt. Can I do it yet? No. Take the kiln out of dead body. You guys watch those shows? The coroner comes in and takes the liver temperature and they do all this stuff around and gather clues and stuff, and an hour later they take the temperature again. From that, they can calculate, figure out what that K is for that specific dead body. And I'm not kidding, like it's real. This is how the science works. Newton's law of cooling as applied to. Okay. Pique your morbid little interest. Okay, in your groups, try this, and I'm gonna like pull the groups up one at a time to solve this. Put that away.
I'm thinking the other body, I thought it was gonna fall out. I mean, it's so serious.
Really?
I was actually gonna show my art project. It's terrible.
and how long it will take for this week. The other two
So you
weeks.
put 0.
Yeah. No, I think it's just two.
Determine the temperature.
Because it was class since Monday.
So many of my erasers have been used up because of this class. I'm the number one eraser user class.
Yeah. Yeah. I think it was okay. That was pretty tough, but tough now. Okay.
So now I'll be over first test. It's asking.
It's very crazy in this equation figure key. Like they had so many letters.
Okay, big question, let's see. Big part, CGG, the one tested. Group 10. Sonia and Sophie. Can you just like fill in the things for all those variables?
Oh, I did.
The original coffee temperature is 185, the room is 75, and the coffee's got that doesn't burn the roof of your mouth temperature at 110. So
And then
what
it
do
gave
you
me
fill in?
156.
So it'd be 75 degrees Fahrenheit plus, in parentheses, 185 degrees minus 110 degrees. And then,
Hold on, Sophie. In the formula, whatever number you chose here should be the same
Oh,
one there.
okay.
So are they both 110 or are they both 75?
we're both 75.
They're both 75.
Yeah.
What's on the other side of the equal sign? 110. And for this, that 0.3, they gave us what K is. They just said, for coffee, the specific heat is negative 0.3. Yep. Where's the 110?
Oh, 'cause that's what you're talking about, that's what you're going for, yeah.
We want the coffee to be 110 degrees. Group 2. Group 2. Angel's like, percent, get away. Group 2, what now? Anything else?
And then subtract the 75 from.
So 35 equals 110 e to the negative 0.3 t. Group 6. Divide by 110. Group 1, L and Company. What do we do now? She's sneering at it. She's like, this is what we do now. What do we do? Convert it to log or ln or something else? Now, what's the other side become? Kamal, what's the very last step? Plug what in? I need to get T. Equals. Divide by that negative 0.3. Okay, guys, what do you get? What is T? How long does it take that coffee to cool? Griffin is writing madly and has, Anya agrees with that number, Dante does too.
Sweet, yeah.
Yeah? Anyone not get this number? Yes. Okay, so the homework is to finish the worksheet. So do the other problems on your own. Compare with your partners.